So in this lesson, we're going to consider the cylindrical coordinate system. So first of all, I'm going to draw up my various axes again. So you have X, Y, and Z. And what we're going to do is we're going to consider some point P, which is given by the cylindrical coordinates S, Phi, and Z. Okay, so what does this actually mean? So if we just map this down onto the axis. Okay, here what we have is S is in fact the distance from the z-axis to our point P. Phi is our azimuthal angle again. Okay, so phi is the angle that is made with the x-axis, and z is the distance above the z-axis. Okay, so for each of these, for S is going to go from 0 to infinity. Phi goes from 0 to 2 pi, and Z will go from minus infinity to plus infinity. Okay, so the big difference here between the cylindrical coordinate system and the Cartesian to remember is that S is the distance from the z-axis, whereas R was the distance from the origin to your point P. So we can also write down our unit vectors. So in the S direction, we have S hat. In the phi direction, we have phi hat. And in the z direction, we have z hat. Okay, and they're pointing in the direction of increase. Okay, so S hat, phi hat, and z hat. Now, we can also write down our infinitesimal displacements for each of these. So in the S hat direction, we have dls is just equal to ds. In the phi hat direction, df phi is equal to s d phi. And in the z direction, it's equal to dz. Okay, so now we have as our total infinitesimal displacement vector dl, which should be equal to ds s hat plus s d phi hat plus d z hat. And we can also write down our infinitesimal volume element, d tau, which is going to be equal to s ds d phi dz.